Hi class, and welcome to GradStats Lab Series, our Lab 3 on correlation and simple regression, this one in RStudio. So our purpose here is to prepare and conduct and interpret a regression, which requires an understanding of the basics of the general linear model. Specifically, regression is based in correlation, and the assumptions that drive or govern correlations carry on over into regressions. Some materials you're going to need are a data set. We're using the survey.dat for this lab, starter tables in Excel, and your Lab3 script that you'll be working with. I also created an example write-up for you to see how our output and information goes into the written form. So download those items and we will get started. Starting off in RStudio, you're going to want to navigate to your files and pick up your Lab3 script. From here we have, the purpose, the goals, and tasks that we are working through in Lab 3, that we're going to import a tab delimited data file and describe the continuous variables in terms of mean and standard deviation. Collect information we'll need to create a correlation table and do the preliminary assumption checks of univariate normality and bivariate linearity so that we can conduct a simple or bivariate regression. And of course, looking through to interpret results and gather the relevant information we need for communicating the findings about that regression. The materials you'll need, some packages we're going to be using are Tidyverse, Core, H Miscellaneous, and LM Beta. And of course, the data set that you need to put in your working directory so that we can import it. And we'll also look at the starter tables in Excel. So a regression, one question that would be suitable for looking at a regression with the question of, does one's perceptions of control, like internal locus of control type of thing, predict their experience of perceived stress? In other words, if I have higher internal control trait, behavior, perceptions, does this have an impact on my perception of stress? So we hypothesize that perceptions of internal control will have a negative significant predictor towards total perceived stress. Our study variables are going to be some of the totals variables in the survey data set: perception of control, total perceived stress, total negative affect, total positive affect, and total life satisfaction. You should have your survey.dat data frame in your working directory, and you want to go ahead and have your Excel sheet. You need to load Tidyverse to get ready for importing the data set. So we're going to use the import utility here. And import data set, which is in your environment area, you want from text reader. And here we have an import text dialog box. Browse to your file, so your survey.dat, and let it load up. Notice that all of our data and our variable names here are kind of all squished together, and R is thinking it's a character type of a measurement. And this is because right now the delimiter is set to comma, and we want to change that to a tab delimited information. Okay, now it spreads out and aligns things properly. Double is a scale level measurement for all of these totals, but we want to change ID to character. And now that one's already set with the right measurement type. We're also going to change the name to Lab3 so that it's less the type when we're coding. Now we're ready to import. So shows us the data frame loaded up. It's in our environment. And we should have 439 observations of 6 variables. So we set the ID to character. There's no factors in there to set because we only included the ID and the continuous factors or continuous variables that we're looking at. So let's take a look at this in the console. All right, we can see our ID variable, our positive affect, negative affect, life sat, total stress, and total control. And we have the means of these right there in the middle. We see that we have some missing variables or missing data, so it's good to know, especially when we're coding. And the first thing we want to do here is describe the variables. And we have pretty much all continuous variables, and we need mean and standard deviation. And we want to save this summary of descriptives into the environment by naming it as its own object so that we can look at it later. So for this, we're going to do, let's call it descript. And it's assigned by we got Lab3 as our data set, and I always forget the keystroke for getting the pipe. Nope. There it is. So it's Shift Command M or Shift Control M is the pipe. Would have taken me less time to just type it, but once I remember it, then I use it all the time. So we want this, we want to summarize. Okay, what we have here, create a thing called descript, and it's going to be assigned by the Lab3 data set. Then summarize if the variable is numeric. In other words, I want this summary for any variables that are continuous in nature. I want a list of the mean and standard deviation, and let's ignore missing values. So now we have this item in our environment, and that is the information we'll need to start building our correlation table, the mean and the standard deviation. Let's take a look at what APA wants in this table. So just to know what we're collecting, we are wanting to know the mean and standard deviation and the correlations for this correlation table. And this is sample table 710 in your APA manual right around page 215. I tend to put the count, the N, in the caption in the bottom instead of having a whole column for it, because tables are a big enough fight in a Word document, and I can easily just incorporate the sample size in the caption itself. So in R, we have our mean and standard deviation for all of these, and we're going to use the pipe operator tool to only select the continuous variables of interest. In other words, we're going to kind of get rid of the ID variable here. There we go. This is create a new item in the environment called lab3.continuous, assigned by lab3 such that I want to select these variables. Now we can run the function correlate to create a correlation matrix on that item in the environment. So I'll need to install and load library core and tell it what to do. So let's see what we have here. We have total perceptions of control. We have all of our variables in this column, and we have them again across the top. And the NAs are just because perceptions of control relating to perceptions of control is just itself. So that's kind of like the ones you see on the diagonal in your SPSS type output. After that, the red are just negative correlations and the black are positive correlations. Other than that, there's no significance to the red text there. So let's keep this. We'll assign it a name. So we just want to take that same item and now give it a name. There we go. And when we look at it in the view, so I'm going to click here, and that's nice and pretty, right? We might even be able to use that in building our table, building our correlation table. So let's check out that starter table. The starter Tables.xlsx that's linked in the description and also in your e-learning. Now this first tab is just descriptions, just mean and standard deviation. So we're going to need more information on ours. So the second tab is table core, and we have to do some updating here, but we can just get rid of this, and we got a column for mean, a column for standard deviation, and these 1, 2, 3, 4, 5, 1, 2, 3, 4. We don't need 5 on this one because 5 to itself is just 1 anyway. And we'll need to update this node because we're not working with grade point average here. Okay, so our variables are total perceived control, stress, positive, negative, and LifeSat. Notice I had to keep not capitalizing, and this is because in the APA book, they're indicating that only the first letter of the variable is capitalized in a table. So I'm trying to stay consistent with that as well. Okay, let's take a look at this. If I can copy this, let me see if I can just copy. Oh, I want all of it. Nope. So I'll just do this much. I'm doing Command C for copy, and then seeing what happens if I paste it over here. Okay, so I can maybe get these. Remember, I only need the bottom triangle here. I don't need the top triangle because it's just a repeat. So maybe I can just go along like this. Oops, that was the wrong place. That's the mean. And now I want this one and this one. All right, well, the numbers are there. Right now I would still need to either get Excel to realize that they are numbers and I only need 2 places, or I might have to edit and actually just type them in so that I can put the asterisks on that. But let me leave it like that for now and see what we do when we get it to Word. I also have the mean and standard deviation that I can get from our descript, right? I have the mean of positive affect, and then the standard deviations. And again, I can label them as numbers, and it'll go to the 2 places, 2 decimal places there. I'm going to center this and make sure everything is aligned to the top, just so it doesn't get weird in Word with some cells aligned to the bottom and some aligned to the top. So I'm going to leave that there for now. I still got to deal with the asterisks. And for correlations, we don't need a leading 0 because correlation does not exceed 1 anyway. So whenever you don't need a leading 0, we don't put it. So I still have some fixing to do on that table, but at least I have all the numbers in there. Let's see what we have next. Notice that we don't have the p-values for these correlations. So we don't know right now if they're significant correlations or not. So we have a different option here. It's called H miscellaneous. It's not as pretty, but it does give us a lot of information. So I want a correlation matrix of the items in Lab3 continuous and using Pearson correlation. So here we have some other information. It still has all the correlations in 2 decimal places, so that's cool. It tells us the n in each of these, so we can see that between total perceived stress and total control of internal states, there were only 426 cases that had information in both of those. But it looks like it goes all the way up to 36, so 426 to 436 seems to be my n there. And for p-values, all of them are less than 0.001 is what they're telling us there. So I can add that information to my table, one that n is from 426 to 436, and I'm not going to need the p-value less than 5, or I can even put 3 asterisks because all of them are less than 0.001. So you just want it to be consistent with whatever you're going to have in the table. Let me make sure my n is italicized so I don't have to worry about that later. Okay, we'll leave it there for now until we start moving it over to Word. Okay, now we have all the information needed to describe the study variables. As far as we have the mean and standard deviation, we have their correlations. We even already started the correlation table. Before we're ready to run the regression analysis, we need to check the assumptions of regression. And first things we're checking are univariate normality and bivariate linearity. And we assess these items by first looking at a plot relevant to those and then running a test. So for univariate normality, we're going to visually inspect the histogram and use a normality test. We'll use Shapiro-Wilks. For total perceived stress, this would be our histogram right there, and our Shapiro-Wilks test is a core R item. We didn't need an extra library for it. And we're seeing that the Shapiro-Wilks test is coming in under 0.05. It's a significant test, which indicates a violation of normality. But when we look at the histogram, it's really not looking that bad. I mean, it's a little choppy here and there, but it's trying really hard for a normal distribution there. So I wouldn't worry too much about that one. Let's look at total perceptions of control of internal states. Now that one's got more peakies going on, and it's got these outliers in the lower end. So that one definitely has more issues with normality. Let's see what Shapiro's test says about it. So definitely a significant Shapiro's test, which means according to Shapiro-Wilks, it violates normality. And again, Shapiro-Wilks is sensitive to large sample sizes, and we have over 400, which is going to be considered a large sample size for Shapiro-Wilks. What we can do to run these remaining histograms and normality tests is just copy your script that you've already written there and go ahead and paste it and just make changes for our other three variables. So we needed T positive affect, we needed total negative affect, and we needed total life sat. Let's see, does it have, yes, it has an E in it. Okay, so now we can run these. Oops. So positive affect, we've got a bit of a negative skew going on and a significant Shapiro-Wilks. Negative affect has a strong positive skew going on and a significant Shapiro-Wilks. And life satisfaction, pretty peaky. A little negative skew. Let's see what Shapiro-Wilks says. Significant. So we can inform the reader both of our visual evaluation of the histogram and of the Shapiro-Wilks. Now, typically the ones we're worried about mostly are the two that are, or any variables that are going to be in your regression. So the rest of this is informational, but the two that you really need to communicate for this write-up is going to be the two variables that are part of the regression, total perceived stress and total perceptions of control. So moving on to bivariate linearity, we also look at a plot and look at a test. The bivariate linearity says, is there a linear relationship between these two variables we're intending to put into the regression? And we do that by looking at a scatter plot because that shows us linear relationships. So we want between the predictor variable, which is total perception of control, and the outcome, which is total perception of stress. And that's the only one we're running in this lab, one bivariate regression. So we want that scatter plot. Using ggplot on Lab3, give me a scatter plot with total perception of control on the x-axis and total perception of stress on the y-axis, and ignore the missing values. So we got that. And now looking at this scatter plot, we can see that we have a negative trend to the data when perception of control is high, perception of stress is lower, and vice versa for when perceptions of control are low, perceptions of stress are high. And there's different things we can do to try to clean up this scatter plot and any plot to help it be more informative to the reader. We can add a low S line. So I'm just going to take what we already wrote, and then I'm going to add to it. I want the low S line. It's called smooth. And we want those same values. There we go. So aesthetics, we still want X being the total perceptions of control and Y being total perceptions of stress. So let's see what that looks like. There it goes. It needed more room, apparently. And notice it says it removed 13 rows of non-finite values. Basically, those are the missing values between those two. So even with the low S line, which is a smoother line than a line of fit, but it is trying to fit the data points as well as possible. And we still see a negative trend when we're looking at the low S line there. Now, what other things can we do to try to clean up this plot when we want to put it into a write-up? This is exactly a good use for AI help. So you can take your code, your basic, this is my scatter plot code, and copy it, and then go over to your ChatGPT stuff and just paste your code in there. Oops. Let me try that again. And what it does is give you an idea as to what it's understanding you're doing. Looks like you're trying to create a scatter plot between these two variables from this data set. And here's how you can modify your code to create the scatter plot correctly. So it thinks we did it wrong, because why else would we be asking it? But we're fine with the actual scatter plot. We can, and it tells you what each line does. So that's kind of cool. We can say add details to plot to make it more readable. Let's see what it comes up to with. You can make your scatter plot more readable and informative by adding various details and customizations. Here's an example with additional details. So it decided to add some color and change the size of the points in the scatter plot. It says that it added labels like titles to the plot, including the main title, x-axis and y-axis, and it applied a theme. So let's see what it found here. The labels might be handy. So let me copy just that part. Well, we'll see what it does. I'll take it from the labels on, and then make sure I copied that, and go back to my R, and let's see. I'll put in the labels, but I need my original plot here. So I'm just messing around, seeing if I can make this a little more approachable. I'll put a plus to add in the rest of these. The labels, I'm going to want it to say something more like perception of control versus perception of stress. Not sure what it's going to do with color groups since I didn't get the color, so I'm going to go ahead and take out that one. And then it does this theme minimal. Let's see what that does. Run it. Alrighty. So now it put on the axes labels and the full label, the main title label. I wonder if I can put my lowest line back in there. We'll see. Copy that and I'll put it here. Put a plus, take out this extra plus because we already have a plus there. And notice how I'm getting a little red item. So it seems like it wants that closing bracket that I took off. Yep. So the brackets have to match, like open, close, open, open, close, close, open, open, close, close, and then the labels. Let's see what that does. Okay, so I still have my labels and I have my lowest line. But thinking about it, I'm going to have to redo this title anyway because it's centered. I'm going to want it italicized. And I think I can do that easier just in Word. So I'm going to come up here to this title, the main title, and just take it out. So I only want labels for the X and Y axes. Let's see what that does. Okay, that looks pretty good. We have the X and Y axes labels, we have a lowest line. So I'm going to export this, save as image, so that I can use it later. Cool. So that's how we are using the scatter plot to evaluate bivariate linearity. We're looking at it and saying, is there a discernible upward or downward trend to the data that would suggest that there is a linear relationship there? And to actually test this, we use a correlation test, which we already got when we were doing the descriptives. We ran a bunch of them. So let's recheck the correlation between total perceived stress and total control, perceptions of total control. So we have a correlation of negative 5.8, 5.81, whatever. And that's a pretty hefty correlation. The level of strength, like you're trying to find out what is the correlation coefficient, is it significant or not? And when we found that all of these correlations are significant, and what is the strength and direction? Well, the direction is negative. When one's high, the other one's low. And the strength at a 0.58 is a strong, a strong correlation, because 0.1 is weak, 0.3 is moderate, 0.5 is strong, and 0.8 is like very strong. So we have confidence that these two variables are linearly related, which is an assumption we needed to check for regression. So now we're finally ready to run the linear model. And a bivariate linear model with just one predictor, one outcome would look something like this. Okay. So we're asking for the function linear model. And what model are we testing? We're testing TP stress predicted by TP coes using the data called Lab3 in the environment. So let's take a look at what this gives us. So it told us what we told it, right? It reflected back so that we know what it was working with. And it gave us the coefficients. The intercept, which is called the constant in SPSS, and that's the value of stress, of TP stress, with not considering any other variable. And TP coes is the impact or the regression change, the change in y, in the dependent variable, for every 1 unit change in the predictor in perceptions of control. So it's negative, like when someone feels more control, they feel less stress. And it changes by a negative 0.28. In other words, stress reduces by 0.2835 for every 1 unit increase in perceptions of control. So good information to have, but we need a lot more information to be able to write up this regression. So we need R to give us more information about this linear model. And whenever we want information about a thing, we're telling R, I want more about this thing. We have to have that thing as an object in the environment. So what we're going to do is take our linear model and give it a name. Let's say we can call it, let's call it stress, is assigned by the linear model of TP stress predicted by TP coes. So we'll run that, and now it's an item in the environment. And I can ask for a summary of that item now. Okay, now we got more info. So we have the formula, we have residuals, coefficients, what significance they are, and lots of information about the test, the ANOVA. So we have, right here is our F-test information. It's saying that the F-test was significant because that's less than 0.05. And the estimate of the F statistic was 215.6. And the degrees of freedom were 1 and 424. The R squared is our effect size. So we needed that. These are all pieces of information that we're going to want for writing up that regression. What information do we still need to be able to write up the regression? We need the confidence interval for that R squared. And we can get it right here in R. We need to use the package called mbes. And the function and formula to get the confidence interval for R squared goes like this. We call it, and in parentheses we give it the value of R squared, how many predictors are there, and what the sample size is. So writing that, and remember R is case sensitive. Our R squared was 0.3371. Number of predictors was 1, because we only have one predictor in this one. And our sample size, that gets interesting. We have that the data set had 439 observations, right? But we have right here in our information about the linear model that 13 observations were deleted due to missingness. So we need to take a look at that and say 439 minus 13, 426. So only 426 observations were in this regression model. Okay, and then we're ready to run. Okay, so here's some information. Your lower limit of the R-squared confidence interval was 0.26368. And we pretty much round to just like 2 places, 2 to 3 places. Our upper limit of the confidence interval was 4093935, so like 4.1. These other two, the probability less the lower probability and the upper probability, is just the 25% at the bottom end and the 25% at the upper end. So if we're taking, not 25, 2.5. So 2.5% at the lower, 2.5 at the upper, those added together is 5%, right? And we were asking for the 95% confidence interval. So it took off the 5% and left us with the 95% in the middle. So we want this number for our lower and this number for our upper, but round it to like 2 places. Okay, so that's for the model. We still need information about the coefficient, like what did we find out about the predictor of perceived control? Well, we found out it is a significant predictor of stress. In our, we'll go back and get the summary again, just to have it right here. Right here, our perceptions of control, the unstandardized regression weight is negative 28347. So in other words, for every 1 unit increase in total perceptions of control, stress reduces with the negative by 0.28347. Is this predictor significant? Yes, it is, because that's less than 0.05 there. So good, we got some information about our coefficient, but we still need a couple more pieces. We need the confidence interval and the standardized regression weight for this coefficient. So for confidence intervals, super easy. Just tell R that you want it. I want the confident of the linear model. I want the confidence interval of the linear model. And there we go. For that regression weight, it could have been anywhere between negative 321 and negative 246. So there's my confidence interval for TP-COAS. To get the standardized regression coefficient for TP-COAS, I will need the LM beta package. So I'm going to run that. And we're asking R for beta standardized coefficient. We're asking it to do that function on the same model, the same linear model that we already have in the environment, and then to save the information to the environment as a new object so that we can check it out. So we want, let's give it the name stress beta assigned by LM beta of the linear model stress. Cool. Running that, now we have stress beta over here in the environment, and let's get a summary of stress beta. Okay, looks a lot like our information from before, right? With the information about the f-test, the r-squared, all of the same information, except now we have a new column here called standardized. And when you have standardized coefficients, the intercept falls out. It's like you're readjusting the whole regression line to center at the intercept. So intercept doesn't matter, it's just 0. But here's our standardized regression weight for total perception of control. And that's the only thing that really changed, is this column right here when we ran that LM beta on the linear model. Okay, and now we have all the information we need for the write-up itself. Let's check out the write-up. Typically, you would have your level 1 results, your level 2 of where you're going first. We let the reader know about the data set, and I put 426 because that's what ends up being in the regression model. You could put both numbers and just make it clear that the data set had 439, but then later when you talk about the actual regression, you would have to make it clear to the reader that only 426 of those had the values needed to be included in the model. You let the reader know that you have a table of correlations, and that's something we still need to do, is see about getting that correlation table into Word. So let's check that out real quick. I have it in here already, but I'd like to see how it crosses over. So I'm going to do Command Return to get a new page, just to try this out. So going back over to our Excel, here's the table, and I still need to put in the asterisks, right? So I'm going to go ahead and copy all of this, Control C or Command C, and then come over to Word and paste, Command or Control V. Okay, it's a little too close to the margin here, so I can select the whole table, getting this, and then go to Layout and Auto Fit to Window. Okay, that works okay so far. Remember, I still need to take out zeros and add all those asterisks, which might make the whole table a little too wide. Let's see. It made it. So not bad so far. Okay, it's not going to be called table core. It would be called something like table 1. Okay, let me just delete that. There we go. So I have my table number, my table title, and everything seems to be lining up. I definitely thought it was going to fight more, but we did a lot of cleaning in the Excel, so it wasn't as fighty here in Word. Okay, and then the rest of the write-up, letting the reader know how assumptions were evaluated, that we inspected the histograms and also ran Shapiro-Wilks. We also looked at the histogram for total perception of control and ran Shapiro-Wilks, and then the assumption of bivariate linearity was looked at visually with the scatter plot. And as usual, you let your reader know when you have a figure that helps explain. And we saw a negative linear relationship, which was also confirmed by a significant correlation test. In the model, so now this is to the actual regression model, we conducted a bivariate regression to evaluate the research hypothesis. Results indicated a significant model. So we're talking about this. This is our stats line where our F-test and degrees of freedom and what it was estimated as. So going back to R, so there's our 215.6 and our degrees of freedom 1 in 424. We have the R squared and the 95% confidence interval. The regression model itself explained about 33.7% of the variation in total perceived stress. So we're getting that number from this R squared. If we can convert that to a percent, it's 33.7%. And it's the model that's explaining the variation in total perceived stress, not just perceptions of control. So first information we're giving is about the model. And then we go into the details about the actual regression coefficients for the predictors. Perception of control was a significant predictor. We have the unstandardized regression weight, the significance level, the standardized regression weight, because that's a form of effect size for that regression coefficient, and the 95% confidence interval of this guy, of the unstandardized regression weight, is what that confidence interval is about. The hypothesis was supported such that each 1 point increase in perceived control predicted a 0.28 decrease in total perceptions of stress. And our prediction equation would look like this. We've predicted this outcome. It has this constant or intercept and this regression weight. And the regression weight is for the predictor perception of control. Cool. And then you have your appendix. Tables come first, and after tables are figures. And you want your figures and tables to be on separate pages when they're in the appendix. So that's all of those. Let me double check our script. That's it for here. So we did a lot here. We were able to check out the descriptives as far as the mean and standard deviations of continuous variables, and we checked out the continuous variables across the whole data set to build a correlation table and be able to communicate about the relationships going on within that data frame. We also checked assumptions, univariate normality, and bivariate linearity by visually checking out the plots and also running tests to evaluate those assumptions needed for regression. And then we went into our linear regression of how is perception of stress predicted by perceptions of control. So good job, and I'll see you in the next lab.